Algebra Unit 7, Lesson 4, Notes 5, Classifying Polynomials. A monomial is a number, variable, or a product of a number and one or more variables. A polynomial is a monomial or the sum of monomials, each called a term of the polynomial. Some polynomials have special names. A binomial is the sum of two monomials, and a trinomial is the sum of three monomials. Take note of the prefixes. Bi means two, tri means three. Similarly, mono means one, and these are all polynomials. So below here I have an example of each. We have a monomial, a binomial. Notice how it's separated by a plus sign. I have 1, 2 terms. Trinomial, I have 1, 2, 3 terms, again separated by the plus and the minus. And then I also threw in there some non-monomials. So when you have a variable in the denominator or a variable with a negative exponent, those are not monomials. The degree of a monomial is the sum of the exponents of all its variables. So you take their variables and you add up their exponents to get the degree. A non-zero constant term has a degree of 0, and 0 has no degree. The degree of a polynomial is the greatest degree of any term in the polynomial. You can find the degree of a polynomial by finding the degree of each term. Polynomials are named based on their degree. Over here is also a chart. If a polynomial has a degree of 0, it is constant. A degree of 1, it is linear. 2 is quadratic. 3 is cubic. 4 is quartic. 5 is quintic. And 6 or more, we just name them 6th degree, 7th degree, and so on. So there was a lot of information there. Let's break it down piece by piece. We're going to fill in a bunch of charts here that are similar to what will be on your homework. So state whether each expression is a polynomial. If it is a polynomial, identify what type. So we have 4y minus 5xz. I don't have any negative exponents and I don't have any variables in the denominator. So this is definitely a polynomial. Notice how I have a subtraction sign. That means I have two terms. This is a binomial. Letter B. Numbers are also polynomials. That you don't have to have a variable to be considered one. So yes, this is a polynomial, and there's only one term because there are no addition or subtraction signs. So it is a monomial. 7a to the negative third plus 9b. I have a negative exponent. This is not a polynomial, and let's write our reason. I'm just going to put negative exponent. This is really for your reference, so you remember why it's not. The last one, 6x to the third plus 4x plus x plus 3. I don't see any variables in the denominator or negative exponents, so this is a polynomial. However, be careful. We have a couple like terms here. We have positive 4x and positive x. We can combine them to be 5x, which would bring those two terms to one term. So this would essentially be 6x to the third plus 5x plus 3, which has three terms, which is a trinomial. So when you're determining what type of polynomial it is, you have to make sure you can't combine any like terms. Okay, let's move along to the next section. Find the degree of each monomial. Basically, to find the degree, again, you just add up all the exponents of the variables. So letter A, I only have one variable, it's an x, and it has an exponent of 2. So that's the degree. If we look at, let's take a look at letter E. I have one variable, the degree is 0. The exponent is 0, I should say. Therefore, the degree is 0. Letter F, I have 3 variables. When I add those 3 exponents together, 2 plus 3 plus 1, you get 6. So that is a degree of 6. You can go ahead and finish those other 3. The terms of a polynomial can be written in any order. However, polynomials in one variable are usually written in standard form. The standard form of a polynomial has the terms in order from greatest to least degree. In this form, the coefficient of the first term is called the leading coefficient. Complete the table below. So here's our standard form. Notice how our exponents on the x, I have x to the third, x to the second, x to the first, and really x to the 0 because there's no x there. So the x's actually decrease, the exponents decrease. And the coefficient of the first term, which is the largest exponent, the greatest degree, that's called our leading coefficient. So we're going to find the degree of each term, put it in standard form, and then find the degree of each polynomial. Looking at 3x squared in letter A, the degree of that term is 2. Now look at 4x to the 5th. The degree of that term is 5. And then we look at negative 7x. The degree is 1. So to put it in standard form, we put each term in order from exponents biggest to least. So 4x to the 5th has the largest degree, so we write that first. Next is our positive 3x squared. And last we have our negative 7x. So that is in standard form. Our leading coefficient is 4. To find the degree of the whole polynomial, you actually just use the largest degree, which is 5. So the degree of this polynomial is 5. And we would call that a quintic polynomial. Let's go ahead and do one more of these. Let's look at, we'll do C. Letter C. 8 is a constant. It has no variables, so the degree is 0. Negative 2x squared's degree is 2. 4x to the 4th, the degree is 4. And negative 3x, the degree is 1. So let's put this in standard form from greatest degree to least degree. So positive 4x to the 4th minus 2x squared minus 3x plus 8. The leading coefficient is, again, coincidentally 4. The largest degree is 4, which means the degree of the polynomial is also 4. Go ahead and finish the rest of this chart. Complete the table below. So it lists some polynomials. We're going to determine how many terms it has, the name using the degree, which has been done for us in this example, and then the name using the number of terms, also the degree of the polynomial. So the number of terms for letter A, we have one term. There's only a negative 2. It is constant. It is a monomial. And since it's a number with no exponent, its degree, or with no variable, I should say, its degree is 0. Letter B, I have 2 terms. It is linear. I know it's linear because the degree is 1. And it is a binomial. Letter C has 1 term, which tells me it's a monomial. The degree is 2, which makes it quadratic. The next one, letter D, I have 3 terms, which means it's a trinomial. And the largest degree is 3, therefore making it cubic. Okay, a little bit different of a chart here. And I'm going to figure this out a little out of order. So we have letter A, our polynomial is x to the third, y, z to the third. There's only one term, so I'm going to call this a monomial, and I'm going to abbreviate for lack of space. Since there's only one term, standard form, I just rewrite it. X to the third, y, z to the third. To find the degree, I add up all the exponents. There's an exponent of 3, 1, and 3. So 3 plus 1 plus 3 is 7. And if you take a look on the front of your page, and there's a little chart on the top right, the name for something with the 7th degree, we just call it 7th degree. 6 and up, we just name 6th, 7th, 8th, 9th, etc. This is a 7th degree polynomial. Let's skip. Let's look at letter C. I have 3 terms, which means it's a trinomial. Standard form means decreasing degree. So I have a degree of 2, degree of 1, degree of 0. So it actually is in standard form, which is nice and easy for us. The largest degree is 2, which means that's the degree of the polynomial. And a degree of 2, again referring to that chart in the front, means it's quadratic. Skip down a few, let's look at letter F. Again, make sure you're looking for like terms, because you do have to combine like terms if there are any. So for letter F, I have no like terms, but I do have 1, 2, 3, 4 terms, which means we just call it a polynomial. After 3, mono, bi, tri, we just call it a polynomial. Standard form, well, let's find the degree of each term. The degree is 2, 1, 3, and 0. So standard form, 2y to the third plus 4y squared minus 4y plus 8. The largest degree is 3, so that's the degree of the polynomial. And 3 is cubic. So specifically, we would call this a cubic polynomial. Let's do one more. Let's look at letter J. Letter J, I have 3 terms. The coefficients, the degrees of each term, that one's 1, 4, and 0. It is a trinomial. Standard form would be negative 3x to the fourth plus 1/2 x plus 7. The largest degree is 4, so that's the degree of this polynomial. And a 4th degree polynomial is also referred to as a quartic. Okay, let's look below. Arrange the terms of each polynomial so that the powers of x are in descending order. So this specifically is talking about the powers of x. So we just take any other variables along for the ride. If I'm looking at the x's, I have x to the first, x to the second, and no x. So the largest one is 3x squared, 3 being the leading coefficient. Then I have minus 8xy minus 5y. Again, we're focused on the x's. Letter C, I'm going to skip. Letter C, again, look at the x's. I have an exponent of 1 for x, an exponent of 2, no x's, and an exponent of 4. So the exponent of 4 will be the first one. Negative x to the fourth, y to the third, z to the third, then this term, plus 6x squared yz, plus 7xy squared, and then minus y to the fourth z squared. Go ahead and finish this page on your own.